So now we're going to apply inequalities to the real world. There's real world uses of linear inequalities in 7.8. So let's remind ourselves about real world linear equations. A company wants to create a mixture of nuts that sell for exactly $40. Right? So this is not going to be an inequality, it's going to be an equation, exactly $40. Peanuts cost $2 per pound. There's our rates. Our rates are going to be our coefficients. Right? So it's $2 per pound for peanuts and $5 per pound for cashews. And it's going to be an equation. And we're going to write and plot a linear function in standard form to show all the combinations of nuts they could sell for $40. Okay, so that is our linear function, right? It's in standard form, so typically we're going to find the intercepts, so we'll make p equal to 0 here, and 2, 0, plus 5c equals 40. Divide both sides by 5. C equals 8. So cashews are on the bottom, so that's 8, 0 is one intercept. We'll make c equal to 0 here. So we have 2p plus 5 times 0 equals 40. Divide both sides by 2, and p equals 20. And so 0, 20 is our other intercept. And it's an equation, and so negatives don't, right? Negative cashews and peanuts make no sense, so we're doing everything in the first quadrant, and we're just going to connect them. And along that line are all the possible combinations of peanuts and cashews that equal exactly $40. And let's see right there. We could put, right, it looks like 4, and what, these are going up by 2, right? 2, 4, 6, 8, 10. So 4, 10 looks like a combination that would, so 4 for cashews, 10 for peanuts, right? That's C, that's P. Those add up to 40 if you put it in there, right? 2 times 10 plus 5 times 4 does equal 40. That's one combination, and there's lots of other combinations along the line. So what is an inequality version of this? Well, right, so we're going to do this once for linear inequalities, and then once, or again, for systems of linear inequalities, right? So this is for all the adult and children who could buy movie tickets up to this maximum price, whatever that is, all right, up to, right? You usually don't have exactly $40, you have up to $40, for instance, okay? And then we'll apply it to a system of linear inequalities. So let's see, movie tickets cost $12 for adults and $6 for children. So 12 is our rate, $12 per ticket, our coefficient for A. For adult, I'm going to use A for adults, as I have in the past, and $6 for children. If we have at most $120, at most, that means it's $120 or less than or equal to 120 at most. So I just wrote a linear inequality, and now I'm going to plot it. So let's plot it. So if A equals 0, we have 12A, oops, 12 is times 0, plus 6c, and you do this with an equal sign. Divide by 6, c equals 20. C is on the bottom, so it's 20, 0 is our intercept there, way over here. So if no adults go, all right, for 120 bucks, we can have 20 children go. Now, it would be a little crazy, but maybe. Depends on the age, I guess, of the children. Then if C equals 0, if no children go, that's how many adults can go. So 12A plus 6 times 0 equals 120. Divide both sides by 12. The adults can go, it's 10 adults, right? Because their tickets are more expensive, so fewer adults can go than children. So 10 is right there, that's our intercept there. It's a solid line because we're saying at most, so it can be equal to $120. And let me draw my line. And then, right, negative doesn't make any sense here, so we don't want to have anything down here. And now we're going to shade anything. Now, right, do we shave above or below the line? This is in standard form. Well, 0, 0, right, we're going to put in here 0, 0. Is 0 less than or equal to 120? Yes. And so it's this area beneath the line. And so that's a real world linear inequality. We have up to $120 to spend. We don't have to spend all of it, right? Maybe we don't even have 20 children who want to go. It's actually more realistic than the equation version. All right, so let's do this again. A school wants to give away t-shirts to their students and has less than $360. So less than $360. If heavyweight t-shirts cost $12 per shirt, so we said use capital H for the heavyweights, and our coefficient is our rate, $12 per heavyweight shirt, and $8 for the cheap shirts, we use C. So that's our linear inequality. So once again, we're going to find the intercept. So if H equals 0, you get 12 times 0 plus 8C equals 360. Divide both sides by, ooh, this does not come out nicely. All right, so C, okay, 8 goes into 36. 4 times 8 is 32. And so bring down to 0. Oh, it does go in this, 45, sorry. And so C equals 45. So C is on the bottom, 45, 0 is right there. That's one of our intercepts. The other one is where C equals 0. So we have 12H plus 8 times 0 equals 360. Divide both sides by 12. H equals 30. So 0, 30 is our other intercept. Right, so the heavyweight shirts are more expensive, so we can't buy as many. We can only buy 30. If we only buy heavyweight, we can buy 30. If we only buy cheap, we can buy 15 extra ones, 45. But do we want 15 extra cheap ones? All right, now this was less than, so it's a dashed line. We don't have exactly this amount. We have some amount less than this. So we're going to make a dashed line. And once again, we're going to put 0, 0 in there. And this is 12 times 0 plus 8 times 0 is 0. 0 less than 360, yes. So we're shading below the line. There it is, and there is the shading. I did these for myself. Can they buy 20 cheap shirts and 15 heavyweights? All right, there's two ways to tell, right? So we're going to look at the graph. 20 cheap shirts and 15 heavyweight. Right? Yeah, they can, right? According to the graph, and this graph is looking pretty accurate, it's below the line, it's in the shaded area, so the answer is yes. What's the other way we could check? We could check with the equation, right? So heavyweight 15, I'm putting this into the inequality, and 20 cheap, is that less than 360? It better be. 8 times 20, that's 160. 12 times 15, let's do that over here, and 180, and so 180 plus 160 is what? I think 340. Is 340 less than 360? Yes. Double checked it two ways. Pete wants to know all the combinations of dimes and quarters that can make at least $5. Okay, so now at least greater than or equal to 5, right? And the rate for a dime, it's 10 cents for every dime. We're going to use D for dimes. And 0.25 for quarters is greater than or equal to 5. Now, this is got decimals in it, and so I could deal with the decimals, but I like to clear my decimals. So I'm going to have to move the decimal twice there. So I'm going to move it twice everywhere. And so this becomes 10D plus 225Q is greater than or equal to 500. All right, we've cleared our decimals. Now I'm going to find the intercepts. If D equals 0, We have 10 times 0 plus 25q equals 500. And divide both sides by 25. 25 goes into 50 twice, so this is 20. So D, this is Q, so Q is on the bottom, so that's 20, 0. And here, Q equals 0. So we're putting in the bottom one, 10D plus 25 times 0 equals 500. Divide both sides by 10, and D equals, whoops, I didn't want to show that, but I did. All right, so equals 50, so it's 50, 0. And you can see our two intercepts, and it's a solid line. But notice now we shade above the line. This is not to the right, it's above. And the reason is this, we can put it in there, right? You put 0, 0 in there, and 0, 0 does not make it true, right? 0, 0 is not a solution, so you shade the other side of the line. Okay, so let's see, are 5 quarters and 35 dimes enough to make $5, right? We're at least $5, so 5 quarters would be right here, and 35 dimes. Looks like no, that would be no. According to the graph, it's just below the line, and again, you could use either inequality, you could use the one with decimals in it or not, to check if that is in fact true. All right, now this is going to be a system of linear equalities. Okay, Pete wants to know all the combination of dimes and quarters that can make at least $5 with less than 35 coins. Right, and plot a system of linear equalities. Show all. So this is a system. So we're going to have, I think, the same. It's just the same one as the last one, right? 0.1d plus 0.25q is greater than or equal to 5. Right? We have the exact same one that we had, and then we're also, and so we're doing the exact same thing, right? We're going to clear the decimals and get, right? We're going to get the exact same one that we just had. And we just figured this out, right? We changed this to 10d plus 25q is greater than or equal to 500, and we found the intercepts. Now we're going to do the other one. So let's see, at least 30 with less than 35 coins. So the amount of dimes plus the amount of quarters has to be less than 35. So we are going to graph that on the same plot. Now let's understand. So we could have 0 dimes. I'm going to do the intercepts here in my head. If you have 0 dimes, then you're going to have 35 quarters, right? That would be over here. If I have 0 quarters, I would have 35 dimes. So then I have to connect those two, right, on this graph. And, oh, it's less than, so it should be dashed. So let me redo that. So we want more than $5, but we want less than 35 coins. Where is the solution? It's this area right there. All right, so the real world system, right? So you need a certain amount looks like you need at least 20 quarters, okay? Or you're not going to get $5 with less than 35 dimes. And there it is. So let's see, can we use 25 quarters? 25 quarters, let's use this another color. Let's use purple. So 25 quarters would be right here, and 20 dimes. And that would be no, it's not in the shaded area because it's going to be more than $5. It's above the red line, but that's more than 35 coins. You can see that, right? That's right. 45 is greater than 35, not less than 35. That's too many coins. It's not a solution to the system. All right, so movie tickets cost $12 for adults and $6 for children, and we have at most $120. All right, so that's our first one. And so I'm going to do these one at a time, right? We're going to find the intercepts. When a equals 0, you get 12 times 0 plus 6c equals 120. Divide both sides by 6. C equals 20, and children is at the bottom, so 20, 0 is our intercept there. If c equals 0, we have 12a plus 6 times 0 equals 120. Divide both sides by 12. A equals 10, so 0, 10. All right, I think this is the one we did earlier. And it's at most, so it's a solid line. Okay, now we're going to do the other one now. So the other one is, I've used up too much space here, so let me just use some of that. And the other one says we have at least 14 people who want to go. All right, this is a real world situation. So we have the people, the adults, plus the children. All right, we want greater than or equal to 14 is the other thing we have to graph. So 14 adults can go, or 14 children can go without supervision. And oh, and I wrote the symbol backwards. At least is great. No, I wrote it right. Greater than or equal to 14. And so we're going to make a, whatever that was. Let's fix that. All right, and there's that one. So then that would be this area up here. And then the red one, right, is shaded below. So let's see if I've done this already. Yes, there's the red one, right? So that's no more than $120 to spend. There's the blue one, graphed more nicely. And there's at least 14 people want to go. And so the solution is this area right in here, right? We want more than 14 people want to attend, and it seems like we can't have too many adults go or we'll spend too much money. Where do the two lines cross? So that's interesting, because that's always where we want it when we're doing a system of linear equations, that right, the solution is where the two lines cross. So let's look at that. It seems like they cross at 8 children and 6 adults, right? 8 children, so and 6 adults. 12 times 6 plus 6 times 8 should be exactly 120, right? It's 12 times 6 is 72 plus 48, yeah, equals 120. So there we're maximizing the amount we are spending. We're spending the entire $120, and we're getting at least 14 people to go. We're maximizing both. All right, let's try this one. A school wants to give away t-shirts to their students and has less than $360 to spend. So less than $360. If the heavyweight t-shirts, $12 for the heavyweight, and the cheap ones now are $8. That's all right. Our first inequality. Let's find the intercepts. Let's try to save some room though. So when h equals 0, right, that's 0 plus 8c equals 360. Yeah, this is the one we did before, where c equaled 45, all right, which is down here. And then c equals 0. We have 12h plus 8 times 0 equals 360. Divide by 12. H equals 30, right? So that's there. And hopefully I've graphed that. And there it is. And now we're going to add that they want to give shirts to at least 50 students. All right. 50 students. So we have H plus C has to be greater than or equal to 50, right? So we can give away 50 of the cheap, or 50 of the, I said that backwards. 50 of the cheap is down here, 50 of the heavyweight is up there, and let's do that. So what is the answer here? There's no solution. There's no way, no matter what, even if they do the 50, there's no way they're going to be able to get 50 shirts and spend less than 360, because if you buy 50 of the cheap, it's still more than $360. And so, all right, so let's practice. The student council wants to sell more than $300 worth of tickets to the dance. So more than, or greater than, I don't like the fact that I used more, because more often means add, but greater than $300 worth of tickets to the dance. Tickets at the door are $3, so $3 for the door, and $2 if you buy them in advance. So again, we're going to find the intercepts if d equals 0. Divide by 2, right? So advance, they could sell 150 advance tickets and make their $300. If they sell no advance tickets, then they're going to have to sell, oops, what did I do here? Right, they're going to have to sell fewer tickets at the door because they're more expensive, right? So then you're going to sell 100 tickets at the door. So we're going to connect those two. And it's greater than or equal to, so we're going to shade. They want to get more than $300 out of this dance, right? If they sold 75 in advance, that would be right there, halfway between 50 and 100. What's the minimum they have to sell at the door? Okay, well, it looks like looks like 50. You can't sell half a ticket, right? It looks like 51 would be the minimum, because if you sell 50, you'd get exactly $300, but we want to sell more than that. But let's just check the math, right? So if we put 75 in advance into the thing, into the inequality, right, you get this, right? 2 times 75 is 150, so I'm going to subtract 150 from both sides. And so we get 3d is greater than 150, divide both sides by 3, and d has to be greater than 50. Well, since you can't buy half a ticket, that means you need to sell 51 tickets if you sell 75 in advance to make your $300. All right, final question. The student council wants to sell more than $300 worth of tickets. Tickets at the door are $3. It's the same one we just did, so I'm not going to redo it. There it is. All right. If the dance hall has a capacity of no more than $125, so no more than, less than or equal to 100, we can't, right? You can't sell above your capacity. So the D plus the A cannot exceed 125. Right, so we have to graph that. So 125 halfway between 100 and 150, all right, in both. And we're going to be a solid line. We're going to, oops, I had already written that, so let's clean that up. It's going to be a solid line. And so where is the solution to this system? It's in this area here, all right, so we need to sell a whole bunch at the door if we want to make our $300. If we sell too many in advance, we'll never make our $300 that we want to make. And so if selling 25 tickets at the door and 100 tickets in advance, a solution. So let's see that. So 25 tickets at the door, 25 would be right there. And 100 tickets, it looks like no, it's going to be not enough money. See, it's in the blue area, right? It makes the blue one true. It's right on the blue line, but it does not make the red one true. And let's just show that. I'll show that in red. So 3 times 25 is 75. And I'm just putting this in the top equation. And 100 tickets in advance, 2 times 100 is 200. That's 275 greater than 300. No, it's not. Right, and you can see it's not in the red shaded area. It's not a solution. Good luck with your homework.